And the next part is y is equal to log x square minus 9. How we find fourth derivative? First, we can convert this log x square minus 9 by using log property into the term log x plus 3 into x minus 3, as this log can be written as y is equal to log this x square minus 9 can be written as x plus 3 into x minus 3 by using simple algebraic formula. So if we have a terms which is in the product form, so by using log property, these two terms can be converted into the sum form, which is y is equal to log x plus 3 plus log x minus 3, simply using property of log. Now our first derivative is 1 over x plus 3 plus 1 over x minus 3, as the derivative of log is actually 1 over the value of this one, and similarly the derivative of log is 1 over x minus 3. So y1 can be written as x plus 3 raised to the power minus 1, and similarly x minus 3 raised to the power minus 1. Now again differentiating with respect to x. Differentiate with respect to x. So y2 is, by using power formula, this minus 1 x plus 3 raised to the power minus 1 which is minus 2, and similarly this minus 1 will be multiplying and this x minus 3 containing a power minus 1 which is minus 2. Again the third derivative, simply using power formula again. So differentiate again with respect to x. We have this minus 2 multiplying with this minus will be 2, and x plus 3 with power minus 2 minus 1 which is minus 3, and similarly this minus 2 will be multiplying to minus 2 will become positive 2, and x minus 3 raised to the power minus 3. Again differentiating with respect to x to find y4. So y4, by using power formula, this minus 3 multiplied to 2 and x plus 3 raised to the power minus 3 minus 1 which is minus 4. Similarly this minus 3 multiplying to 2 will become minus 6, and x minus 3 raised to the power minus 4. So y4 minus 6, this x plus 3 with power minus 4 can be converted into the denominator. This will become x plus 3 raised to the power 4, and similarly this x minus 3 converted into the or shifted into the denominator, which will become x minus 3 raised to the power plus 4. And we have minus 6 as a common factor. So finally the fourth derivative will become 1 over x plus 3 raised to the power 4 and 1 over x minus 3 raised to the power 4. Now question number 5. If x is equal to sine theta and y is equal to sine m theta, then show that 1 minus x square y2, this is actually second derivative, minus x y1 plus m square y is equal to 0. So we have x is equal to sine theta and y is equal to sine m theta. Theta can be written as sine inverse x, because this sine will shift to the left hand side, will become sine inverse x. And so y, as y is equal to sine m theta, so just put the value of this theta, y can become sine m sine inverse x. So we have y is the function of x. We can easily differentiate 2 times. This sine shifted to the left hand side will become sine inverse y, and on right hand side m sine inverse x. To differentiate, applying derivative on both sides, the derivative of sine inverse y, 1 over under root 1 minus y square, as we have the formula of inverse trigonometric functions, which is in exercise 2.5. So we have a derivative of sine inverse y is 1 over under root 1 minus y square, and then derivative of y, which is y1. And on right hand side, m is the constant term, and derivative of sine inverse x is just simply 1 over under root 1 minus x square. Cross multiplying this under root 1 minus x square multiplied to y1, and this m will multiply to this under root 1 minus y square. Squaring on both sides, 1 minus x square into y1 square, and m square is equal into 1 minus y square. Now to differentiate, again to find left hand side, the second derivative, we have this one. Now to find y2, we just differentiate this one Squaring on both sides, which will become 1 minus x square y1 square is equal to m square 1 minus y square. So this one is actually in the form of first derivative. Now to find second derivative, or to prove our required result, we have to find second derivative. So we apply differentiate with respect to x. So this one is actually a product of two terms, 1 minus x square and y1 square, and this is also a product of two terms, or just this one is multiplying constant term to the variable 1 minus y square. We have 1 minus x square, y1 square is equal to m square 1 minus y square. Now again differentiate to find second derivative. Differentiate with respect to x. So we have on left hand side, we have in the form of product terms 1 minus x square and y1 square. So 1 minus x square will be as it is, and derivative of y1 square will be 2y1 by using power formula, and then derivative of y1, which is y2, plus y1 square will be as it is, and derivative of 1 minus x square will be minus 2x, because derivative of 1 will be 0. And on right hand side, m square is the constant term, so will remain same, and derivative of 1 minus y square will become minus 2y, and then derivative of y, which is y1. So on left hand side, 2y1 taking as a common factor, so we have 1 minus x square y2, and this minus plus minus y1 and 2 is the common factor, so the remaining part is x into y1, and on right hand side we have just minus 2m square y1. This 2y1 can shift it to the right hand side, 1 minus x square y2 minus xy1, and on right hand side we have minus 2m square y1 divided by 2y1. So by simplifying, that will become 1 minus x square y2 minus xy1 is equal to minus m square y. And by converting, or by shifting this minus m square y to the left hand side, which will become our required proof, so 1 minus x square y2 minus xy1 plus m square y is equal to 0, which is required result or required proof. So finally we have our proof.